Oh, I have to tell you about this. The cult of model accuracy.
Oh gosh.
That was a thing, right? So like when you build simple statistical models for systems that are linear, you're expecting R squareds of, like 0.9 is like kind of fine. And then you're seeking like 0.95, 0.96.
Right.
When you do the R squared of these very complex models, and for all of the models in Citrine, I just want to tell people out there, it's like they were 0.6, okay? And then you look at that at first, and everyone looks at that first, and they go, ha! They freak out a little bit. And then they go, this model won't be able to tell us anything. Like, there's so little signal. And then you just have to go, listen, when you have 0.6 and you look at the cluster of points, it means that you're starting to be able to understand which things are good and which things are bad. And it's pointing you in the right direction, even if some of the errors on those points are large. And with every cycle, you learn and the accuracy becomes better. Or you decide, you know what, I've topped out on accuracy and I need to bring in more experimental points, a new chemical space. We did that 2 or 3 times, and that was really critical. In the 10 or 11 cycles of learning to get to those 6 awesome candidates, there were a lot of points where our model saturated and it just wasn't giving us anything new. So we're like, okay, we need new chemistry to bring to the table. We add a little bit more, model started learning again, and then it moved forward. The other thing is descriptors. So y'all have a lot of really great descriptors on the platform. There's like 100 and something, right? Even more than that, probably. Yeah. And those descriptors are really quick to calculate. They give you some good information about individual chemistries, but we also have more sophisticated descriptors, right, that we could do using density functional theory, or actually more exciting to me is like these AI approaches to density functional theory, where you can actually quickly, on the same time scale, in seconds or minutes, get, lots and lots of data points.
Surrogate models and that kind of thing.
Exactly. And so when we add those into the platform, that also helped enrich it. So I'd say it's like, if at first you don't succeed, it doesn't mean it will never work. It just means that, okay, like, what's happening? Why do I need new experiments, new chemistry, new models, new descriptors? There's lots of options to try.